Hello, Daniel here. Welcome to my introduction video to NestKing. In this video, I want to give you a rough overview over the main NestKing functionalities. And for those of you who are not familiar with NestKing, this presentation should also give you a short impression what NestKing is used for. So let's start. Continuing there, where Tina has finished her presentation, here you can see the outcome of CATIA. By displaying the position numbers, you can see that each geometry exists of a high number of elements, which makes it difficult to manipulate, respectively even causes some problems with the cutter downstairs from time to time. For this reason, we first optimize this imported geometry by simply pressing the optimization button. Now the geometries are not just simplified, but also the right layer is assigned. The outer geometries, indicated in red, are on layer 3. Inner geometries, displayed in yellow, are on layer 2. But no worries, you don't have to remember these numbers. Just enter the sketcher area. In the toolbar, you will find the layer selection box. Here you can select between layer 0, the design layer, just supporting you for generating cuts. Geometries and text on this layer have no influence on the cutting generation process itself and are also not considered for nesting. Next, layer 1 is the so-called text layer. Same as with layer 4, texts on this layer are printed by the cutter downstairs and can be used to label the cuts. Layer 2 and layer 3, as already mentioned, are inner and outer geometries, and these layers are interpreted as cutting lines by the cutting machine. As you can see, there are several other tools which can be used to modify all geometries. Respectively, the green ones are used for measuring. But don't worry, I don't want to go through all of them, but just show you a short selection. When I switch back to the picture showing the CATIA model, which Tina has already used before, you can see that there is a small radius, which is not covered with any ply. In order to cover this area with some material, we have to offset this area, and therefore we have to know the radius, respectively the length of this area, which can be measured in CATIA itself, and in this case we have a length of about 7.8 millimeters. So the line we want to offset is this one, which corresponds to this cut here. So there are several possibilities to offset this line down here. The first one I would call the AutoCAD-like approach. Therefore, we first have to break this geometry into the pieces like this, and then we have two geometries. And this down here is the one we want to offset. Therefore, we choose the offset tool. On the one hand, we can use these buttons in the toolbar like this. Just click, for example, offset using round edges and offset values. Or otherwise, we can also use key shortcuts. So when I'm clicking the O key on the keyboard, the software already suggests offset, and then we just have to click enter or space, doesn't matter, and the tool is also active now. Next, we can select the offset geometry. Here we can enter the offset value. In this case, we need 5.8 millimeters. We entered 5.8 millimeters, and then we just select the offset direction, which is down here. As you can see, NestKing also adds the offset value if wanted. You can also deselect this function if you want. So this line is on the wrong layer, therefore we can switch the layer. It's already stated before, we want to have layer 3. We can also change the layer by just selecting the geometry and press key 3. This is number 3 on the keyboard itself. If you press 2, layer 2 will be activated, layer 1 is the text layer, layer 0 design layer, and so on. But in this case we want to have layer 3. This one should be on layer 0. And yeah, in the next we also want to connect them, of course. Therefore, in AutoCAD we would have to extend and trim, stuff like that, for both sides. In NestKing we have the so-called join function. We can just select the first, the second, and it will extend and more or less trim automatically. Perfect. Now these are still separated, these two geometries, and if we want to connect them, we can add, for example, mark. We still have the join function activated. Just mark this one and mark this one and press connecting. So that's what we want. So what steps are necessary? Break geometry, offset geometry, set layers, trim and extend with AutoCAD. With NestKing we already have the join function, and finally connect. So we need 5 steps to get this final offset. Actually, I've just recognized this week when preparing for this presentation today. And there are not just one offset to be generated for all these splices here, especially if we consider that we also have to generate the whole stack up with, in the best case, just 4 to 5 layers of material. So we are talking in this case about 20 to 25 offsets per layer and 100 offsets for the whole part. And this is just a tiny part of the whole gearbox. And the goal of the software is definitely not to copy AutoCAD, but to make it more suitable for generating cuts. So as you can imagine, there is already a new tool which can be used to generate offsets, and it's a dialogue-based tool. It's called Offset Plus. If you click on it, the offset dialog will appear. And for example, we can choose the start point first. This will be this point, select an end point. Therefore, we'll use this one. And we will see the effect of these changes live now. So change the direction of the offset, change the propagation direction. So this is more or less what we want. We can also add some slices if we want. Add the offset text, remove or leave the original geometry. Connect if you want. In this area we can select, for example, also the full basic curve. Then the whole geometry will be offsetted. We can also add a distance value like this. If we reduce or increase the value, for example, it affects, as you can see, on the area on the left. But in our case, we want to have the endpoint. Straight edges, we'll switch back to the full basic curve, and round edges affects more or less the behavior of the offset line on the edge area. Okay, now we want to go back to distance, and voila, it's just one easy step and we get the required offset. The next tool I want to show you are the so-called NestKing commands. These commands can be used to add additional information to the data. For example, if we want to add some labels to these 5 cuts here, we have two possibilities. The first possibility is, for example, the most common way. Just press a text dialog, add, for example, step 03, put it to the text layer, press OK, then copy this information to each layer, to each cut, of course. But what happens if we want to change this text now? We recognize, oh shit, it's not layer 3, it's layer 2. We have to change each single text box now. So that takes a lot of additional time. So there's also another way to do this. Therefore, I just undo the previous steps. We can also put a frame around these layers, put them on the so-called command layer 9, and then we select the label command down here. You can see here several commands which can be used, for example, to add some materials, to change the nest name, and so on and so on. Okay, we are happy with the label. The label, the value will be step 03. Press OK, and then just add this into this command frame. Now all cuttings inside this command frame will be labeled with step 03. Another possibility is, for example, if we want to add a rectangle, just press RE via the keyboard, or you can also use the rectangle button over here. Draw the rectangle. You can modify the rectangle by simply double clicking 15 times 15 millimeters high. And let's say we want to have this small cut 10 times, for example. We can add an additional frame, command frame, and just write 10 times. So it's very intuitive, I would say. Perfect. And we will see what happens with these cuts later on. So now let's leave the sketcher. NestKing is also equipped with a materials management system, which you can find over here. The first is the global material catalog, which is stored on the PTC server and is accessible to anyone with NestKing installed. Then you can also set up your own local material catalog, which is only stored on your local computer. And finally, there's also the file-based material catalog, which means that all material information is also stored in the file. NestKing automatically checks if the material you use in a file is also listed in the global material catalog, and if so, automatically links them together. This is important because if for some reason a material in the global material catalog is replaced by another material, the material management system will recognize this and automatically suggest the new material when you open a file containing the replaced material. Back to the buttons. Generate master cuts will be discussed afterwards. Next is the automatic label button. If we click this, the pre-nest setting dialog will appear. Maybe interesting for you is the combine small cuts in the subnest function. In this case, we have a maximum size of a cut limited by 20 times 20, which means if a cut is smaller than the stated size here, it will add it to a so-called subnest. The number of cuts in such a subnest is also limited in this case to 20. Another useful functionality is, for example, the use unique label size function. This means if we have a small cut with less space, the text height of the label plotted on it is, for example, just 5. And in the opposite, if the cutting size allows it, 10 will be used instead. So small cuts are labeled with smaller labels and bigger cuts are labeled with bigger ones. We will also see this effect later. Now we press the OK button. So here you can see the Nest dialog, which shows the material we are using. It's the default material. It's possible to do some changes, to edit, for example, the material width, the length, also the margin top, bottom, margin left and margin right. Do some nest setting changes, and here we can see the final nest width of 1240 millimeters, which is calculated out of the 1250 millimeters of the material width minus the margin top and margin bottom, and the nest length, which is more or less limited by the workspace itself, minus margin left and right. Okay, then next we can, for example, push the nest button, and the nesting will start. We can also skip that process now. Here we can also see our small cuts, which are added via the NestKing command and are combined via the subnest functionality I've explained before in the pre-nest dialog to a single batch. And this is also very helpful, for example, for the cutter lady or man downstairs. Now he or she can easily take the whole subnest and has not to worry that some small pieces are forgotten on the material table or even get lost. And also for the clean room workers, things are easier as well, as you can imagine. With this tool, it's also possible to simulate the cutting process. Press here. We can also switch the simulation speed to make it a bit faster. Also, for example, 20. Now you can see how the cutter cuts out each single part. Perfect. On the right side, you can also see the estimated overall cutting duration, which is also important for our Ulysses, so that we can add the right process time. Yes. Okay. Now I will proceed with the so-called generation of the master cuts. Therefore, I just load the CATIA output file again. Next, I just press the generate master cut button. Then it will ask if the cuttings or the geometries should be optimized yet. Let's say yes, press OK. And now we will enter this new area. The first step normally is to open the master table. In the master table, we can add all the steps we want to use. Let's say in this case 6 steps. Maybe we also want to add a non-cut step, for example, called change tool. Okay, what else can we do? We can, for example, change the orientation to 45 degrees for step 2 and step 6 as well. We can also change the material. For example, we can use one of the global material files. Just take the first one, press OK. And so we are fine now. Press OK again. So next we can enter the sketcher error. First, if I open the previous picture again, showing the CATIA model with all the plies, we can see how they are arranged actually. So this is the center part over there, and this section goes here, this section goes here, this section goes somewhere here. And also this is arranged a bit wrong because this part here is somewhere in this area. So first I would suggest to rearrange the master cards. So each green piece in here is a single master card. So now let's do it. Take this to this place. This is shifted here. This is shifted here. Let's shift here. This needs to be rotated, therefore I just use the rotate 180 degrees. Rotation tool does the job, and this one is shifted somewhere here, and this can be put here. Perfect. Now we can split each master cut into several segments. In this case, we need 4. The same with this master cut. Also split it into 4 pieces. Here we are using something like that. This also comes together. Perfect. This is okay. Then this master cut also needs to be splitted. This one moment. This is this part, and there is another part somewhere. 1, 2, 3. No, we already have all pieces. Perfect. Okay. So this segment goes here, this segment goes here, this segment goes here, this goes here. Perfect. So we split this one here finally. Split segment. 1, 2, 3, 4. Okay. Now we have our splitted master cuts. Next, we can link the generated segments together, like this. Link this. Oh, there's something missing. Just press the escape button to leave the link. The linking tool, split again. Let's take this one. Somewhere here. Perfect. Okay. Okay, then we can link them as well. Just press this. Link this together. Link. Let's do it the other way around. Link this, and link this piece. And this is somehow we also have to split this one more time. So we go into the master cut to dialog, and now we can proceed. This is somehow related to this. This is related to this. Actually, this point not even really matters because we are using the same properties, the same offset value for this, and therefore it makes not a big difference. We also want to link this one to this one. Perfect. This to this. I'll set the final links. So there are quite a few of them. Oh no, that's the wrong one. It's already selected. Take this and this as well. So now I think every segment has its appropriate counterpart. It looks good. So we have altogether we have 14 of them. So now we have finished with the linking process and we can go for the first shot. So just leave the sketcher area again, and then we can press the generate master cut output button here. Now it's asking if we want to auto connect all neighboring offset segments. Just say yes. And now you can see the outcome of the first trial, more or less. You can see the system automatically adds some additional information over here. For example, this all labels in here are labeled with step 1. All cuts are labeled with step 1, of course. The angle is 0 degrees, rotation is 0, and the material we want to use is the global EEE, is the EEE 48 in the global material catalog. Perfect. It also does all the offset material work for us. So as you can see, it's much faster and simpler to use. Let's see what happens. Yeah, it also cuts material somehow and somewhere, but actually the output is not that bad, I would say. What we can change, for example, is that for this center part here, it gets quite small if the offset is 50 millimeters into this direction. To avoid this, we can, for example, go back into the sketcher area. Double click is not what we want to do. We want to simple at the direction, just in direction of the second segment. This is the second segment, and the segment with the point here is the first segment. So the overlapping will just go this direction, segment 2. Now you can see it's already adjusted. 5 millimeters are also okay. Let's do this for all of them. Okay, segment 2, segment 2, and segment 2 again. Okay, perfect. Now we go back. We can save if we want and press the auto. So now we can see here the final output with the redimensioned cuts, as we can see here. Also the steps are added as well, so everything seems fine. Now we can try to finally nest all cuts. As you can see here, now we have the separation between the materials. So the step 1, I would say, will be produced by this material, and step 2 will be for step 2, the default material will be used. We can, for example, nest it now. This already looks pretty good, I would say. Just click skip. We can save it in whatever data format we want to have it. For example, ZCC file. That's the format of our cutter. And yes, press simulation again. And let's see how the cutter path will look like. First he prints all the labels, then he cuts out all the plies. Always starting with the inner cutout, and then the outer geometry at last. Estimated cutting duration, something about 15 millimeters. Perfect. So that's the end of my presentation. If you have any questions, of course, do not hesitate to contact me, and bye bye.